In this segment, we are going to see two concepts from enhanced entity relationship model. We will see the process of specialization and generalization. Specialization is the process of defining a set of subclasses of a superclass. So let's see, we have a superclass. We have a superclass, for example, employee. Now, from a superclass employee, we can create a bunch of subclass. Okay, create a bunch of subclasses, and the process of creating subclasses from the superclasses is known as a specialization. Okay, so why this is known as a specialization? Here we can visualize the thing is that each employee means the general concept of employee. Okay, so each employee means the general definition of employee. So in your company you have bunch of employees. Now each employee means the general definition of employee. Each employee has some common attributes, some general attributes. Okay, now from this general employee you can actually categorize them, you can specialize them based on some attribute. Okay, for example, secretary is a special kind of employee who has a special attribute like say typing speed. Okay, so engineer is a special type of attribute who has a special engineer is a special type of employee who has a some special attribute or some distinct role. Okay, technician is a special employee, okay, who has a distinct role other than all general employee. So here this specialization is done based on job type. Okay, so the set of subclass must be done based on some distinguishing characteristics of the entities in the superclass. So we can have several specialization. We can have more than one specialization from the same superclass. Okay, for example, the employee can be specialized into three subclass like technician, engineer, and secretary. And the same employee superclass can be specialized into another specialization like salaried employee and hourly employee, and that's another specialization based on a separate attribute method of pay. Okay, now how do we represent specialization? We can represent specialization diagram using the diagrammatic notation. So the subclasses will be connected to a circle that represent the specialization. The circle is also connected to the superclass. Okay, so how do we represent them? We have a superclass, there will be a circle, and there will be the list of subclass. Okay, the circle will be connected with the superclass, and the circle will be connected with also the subclass. So attributes of the subclass are specific or local attribute. Okay, say we have employee, we have engineer, technician, and secretary. So the attributes that we have with the subclass, they are only specific to the subclass. Okay, these are the local attribute for each of the subclass. All right, say the typing speed of secretary. All right, the subclass can also participate in specific relationship. All right, now let's see, each employee has a relationship. Okay, so each employee has a relationship with department. Okay, now we know it means that each employee has a relationship with department. So that means engineer has a relationship with department, technician has relationship with department, and secretary has also relationship with department. But each of the subclass can have a specific relationship. Now let's see, technician has a specific relationship with another entity type. That means actually only the technician can participate in this relationship. Okay. So here in this example, we can see that each subclass may have some specific attribute. Okay, so these are the local attribute to this subclass, but the attribute that belongs to the superclass, that belongs to each of the subclasses also, means each of the subclass inherits all the attributes and also the relationship from superclass. But here hourly employee has a specific attribute pay scale and also has a specific relationship belongs to. That means actually only the hourly employees can participate in this relationship. The manager has a specific relationship with project. That means only the manager can participate in this relationship. Now generalization is the reverse of the specialization process. So if I have multiple classes with common feature, okay, I can create a general class using the common features of the classes. Okay, now let's see, I have couple of entities like that. Okay, say I have some engineer, so engineer, technician and secretary. I have couple of entities with couple of entities here. Now each of the entity has some common attribute. For example, each of the engineer has name, SSN and let's say type. Now each of the technician has name, SSN and let's see some special attributes, say grade. Now each of the secretary has name, SSN and typing speed. Okay, now I'm saying that I have multiple entities, but multiple entity type has some common attribute. So why don't I create a general entity using the common attributes? So in this step, actually this is a reverse process of specialization, where I'm going to use this subclass and create a superclass out using them. So now here what I'm going to do, I'm going to create a superclass or like a general class. So I'm going to cut all the general attribute or some common attributes from them, and I'm going to create a single entity type combining with all the common attributes like employee with the some common with all the common attributes name and SSL. Okay, so at the end they look like same, all right, but here the process is that the process first we are going to have a list of subclasses, then we are going to look at them and we can see them, they have all the subclasses has some common attributes. Okay, so why don't I take all the common attributes and I form a superclass using all the common attributes. Okay, so at the end this will look like same, but it's just the reverse process. It's just the process of having the subclasses. Okay, first having the subclasses, then generalize them into a superclass. Okay, now employee is a general class, all right, that has some common attributes which belongs to also all the subclasses. Okay, now the original subclass here, originally will have all the subclasses, then in this process the original subclass will become the subclass and I will create a superclass. Okay, that will be the general class. All right, so here in this example, let's see, initially I have couple of car and truck. So each car has max speed, vehicle ID, license plate number, price, number of passenger. Now truck has also price, license plate number, vehicle ID, tonnage and number of axles. Now I see that Now this entity has couple of common attribute, say vehicle ID. Okay, each car has also license plate, truck has also license plate. Okay, each car has a price, truck has also price. Now why don't I take all the common attribute and I form a general class with all those common attribute. Okay, now the special attribute will belong to the subclasses. All right, so if I think about the difference between generalization and specialization, the diagrammatic notation sometimes can distinguish this process. All right, but sometimes actually people or user database designer, they do not use notation, they do not use different notation because sometimes it is unclear or subjective. Okay, now at the end they may look like same. Okay, generalization or specialization, whatever we talk about, that means actually um, having superclass and superclass having multiple subclass. Okay, and the relationship between superclass and subclass will be same in both process. All right, but sometime actually people can have different diagrammatic notation. For example, in the specialization I have superclass to subclass. First I have superclass, then I have the subclass. Okay, all right, and in the generalization I have first subclass, then I have the superclass. Okay, so here people can use two different diagrammatic notation like that. Okay, so to distinguish whether this is specialization or generalization. But sometimes actually people may not use two different notation. For example, here arrow pointing to the generalized subclass represent the generalization. So arrow pointing to the generalized superclass represent the generalization, like here. Okay, so if the arrow points to the superclass, okay, that means it's a generalization. But if the arrows pointing to the specialized subclasses, that represent the specialization. Okay, so here we are going to represent arrow that will point to the specialized superclass. All right, all right, but as we are saying that they both look same at the end of specialization and generalization, and the relationship between the subclass superclass are same. So sometimes actually in this, especially in this chapter, they do not use the notation because it is often unclear or subjective as to which process was used to reach the final design. Okay, but at the end the final design means the same. So if you even skip the diagrammatic notation or you use only one notation, it means actually same. So data modeling using specialization and generalization, each superclass or subclass represent a type of entity as well as collection of entities of that type. Okay, so each subclass superclass will be displayed using rectangles in EER diagram. So whether this is subclass or superclass, they all are actually type of entities. Okay, so we are going to use the same symbol, the rectangle symbol, to represent both of the subclass or superclass. All right, we can call all entity types classes, whether they are entity type, superclass or subclass. Okay, in object oriented terminology, each of the entity types are known as class. Okay, and each of the entity, different entity of that type, they are known as object or entities in the entity relationship model.